This is section 3.1 and 3.2, dealing with one-step equations, isolating variables with one step, and they're going to include fractions. So 3.1 is addition and subtraction, 3.2 is multiplication and division. So we're going to do with each of these. So we again look and see what's happening to the variable. In this case, 1 is being subtracted, so we are going to do the inverse of subtracting, which is adding. Now, when we have fractions and whole numbers, we have to find equivalent denominators. So they need to have the same denominator of 5. So 1 can be written as 1 over 1. So what times 1 equals 5? Well, 5. So whatever we multiply the denominator, we have to multiply the numerator. So we get an equivalent fraction in the same denominator. Those are going to cancel, and you're going to isolate your variable b. And now, since we have like denominators, we're going to combine the numerators. So we have negative 9 and positive 5, which gives me negative 4/5. And that would be my answer for number 1. Number 2, we have a positive 3/5, so we would subtract 3/5, subtract 3/5. These cancel. You're left with n on the left side. We need common denominators. Common denominator is 10. So 5 times 2 is 10. So negative 3 times 2 is negative 6. Notice I kept the negative in the numerator for both of those because we need common denominators. We can't have the negative on the bottom with 10 and have the upper one be positive 10. They wouldn't be like denominators. So I'm keeping those negatives up in the numerators so my denominators can still be the same. So negative 9 and negative 6 makes negative 15 tenths. And whenever we have fractions, we always want to make sure that we reduce all solutions. We want to be able to reduce that or simplify, also called simplify. So what number goes into 15 and 10? 5. 5 goes into negative 15, negative 3 times. 5 goes into 10 twice. And I'm going to leave it as an improper fraction. This is also negative 1 1/2, which is okay also, but I'm going to work with improper fractions. There's no reason to convert it. That's called converting, not simplifying. That is not, when we change it from negative 3 over 2 to negative 1 1/2, that is not simplifying the fraction, that is converting it. So I'm going to leave it in improper form. Here we have 2/3 that we have to get rid of. It's being added to n, so I'm going to subtract 2/3. Let's move this over a little bit so I can convert. I need common denominators. My common denominator between 6 and 3 is 6, and 3 times 2, so negative 2 times 2 is negative 4. So 19 and negative 4 makes 15/6 over n. We're going to reduce that. Now, the number that goes into the largest number that is divisible into 15 and 6 is 3. So 3 goes into 15 5 times, 3 goes into 6 twice. And I get 5/2, or 2 1/2 is also acceptable. Come on. I'll just put the variable there just for consistency. All right, x minus 1/4 equals 3/2. So I'm going to get rid of that negative 1/4 by adding 1/4. My common denominator is 4. So 2 times 2 is 4, so I have to multiply the numerator of that fraction to 6/4. X equals 7/4. Or x equals 1 3/4. I like this one. So the first thing we need to do is we need to get rid of those double signs. So we're going to simplify this in a way. It's just writing it in a better equation. This makes it a little bit easier to see what the inverse or what's happening to the variable 4/3 is adding it. So I'm going to subtract 4/3. I need common denominators. I already have them. So that gives me -6/3 equals x. I need to simplify that, and I get -2 equals x. I cannot leave it as -2/1. That'll always have to be simplified. Here, we're going to subtract 3/4, subtract 3/4. You're left with n equals, let's get common denominators, times 2 times 2. Again, I'm going to keep that negative in the numerator. So that's -1 times 2, which is -2, which gives me -5/4. Seems very similar to a problem that I've already done. No, 4/5 was the first one. All right, everybody okay with that? Yep. Here, let's subtract 9/5, subtract 9/5. We have common denominators. So 14 minus 9 is 5/5, and we would have to simplify that. That is not considered an improper fraction. That's just not simplified. So we have -76/15 equals x minus. Now, notice here, I'm going to convert all my mixed fractions to improper. That's something I'm always going to do also. So 5 times 1 is 5 plus 2 is 7. So that makes -7/5. Do not make the mistake of doing 5 times -1 plus 2 to give you -3. That's not how it works. The sign is separate to, and this whole entire thing is negative. So I'm going to combine those, and then I'm going to convert that mixed number to an improper. And now I'm going to add 7/5. I'm going to add 7/5. I need to find congruent. So my common denominator is 15. So it stays as -76. This is times 3 equals 15. So 7 times 3 is 21. So I have -76 and +21, which gives me -55/15 equals x. That's my denominator. And, oh, that reminds me. Nope, not that one. Or n equals -1 and 1/4. Isn't that funny how my brain went back to that? I didn't forget that. Here we're going to reduce. I'm going to reduce that by 5. 5 goes into -55 11 times. 5 goes into 15 3 times. So that's the answer that I'm going to look for. Keeping your answers on the assessment, I'm going to expect all answers to be in improper fractions. You can also have what's that, 3 2/3 is also acceptable. All right, here's our first multiplication one. What's happening to the variable? It's being divided by 2. So the inverse of dividing by 2 is multiplying by 2. So we're going to multiply both things by 2. That 2 is in the numerator, so it multiplies the 4. It cannot cancel with the 5. So we get 8/5 equals n. And then you can make that 1 and 3/5 in mixed number. Here, I'm going to do this. I'm going to get rid of this. No, let's do this. So we have 4/7 n equals -2. So the inverse of multiplication. Inverse of multiplication is division. That's the easy one, and we know that. But the inverse of multiplication is also multiplying by the reciprocal. And we're going to use that quite a bit in these lessons. So instead of dividing, we don't want to divide by 4/7. We don't want to use the division inverse because, what are you going to do with that? A lot of students don't know how to handle that. So we're going to move away from using division as the inverse of multiplication. What we're going to do is we're going to use the inverse of multiplication as multiplying by the reciprocal. So we're going to multiply by the reciprocal of 4/7, which is 7/4. And we're going to do that. So we get n, because any number times its reciprocal is always going to equal 1, and that isolates, that gets our variable by itself with a coefficient of 1. And here we're going to turn -2 into a fraction as -2/1, and we're going to cross cancel. A lot of students don't cross cancel here. You really, instead of making it -14/4 and then reducing, it's much more efficient to deal with these numbers when they're broken up. So this becomes -1, 2 goes into -2 -1 times, and 2 goes into 4 2 times. So now we multiply across numerator times numerator and denominator over denominator. Let's make that in consistent color. So we get -7/2, or n equals what's that, 3 1/2 is also acceptable. So mixed numbers are acceptable. It's not that I won't accept a mixed number. It's just that it takes you a mathematical process to convert that from an improper. And whenever you add another step, you increase the ability to make a mistake. So be careful of that. That's why I always say if it's correct right here and it's no more correct, why risk turning it into there? So that's why I always keep it as an improper fraction. So again, the first thing we're going to do is we're going to convert this to an improper fraction. 3 times 2 is 6, plus 1 is 7/3. N equals 7/12. We're going to multiply by the reciprocal. We're left with n on the left side. 7 and 7 cancel because 7 goes into 7 once. 7 goes into that 7 once. And then we're going to cancel the 12 and the 3. 3 goes into 3 once. 3 goes into 12 4 times. And we're left with 1/4. That's a good one. I like that one. We're going to convert. 5/4 n equals 23/4. You should be able to convert those mixed numbers to improper fractions that quickly, that easily. If you can't, then you need to practice that. Multiply by the reciprocal, which is 4/5. You're left with n equals, the 4's are going to cancel. They don't make zeros, they make ones, and you're left with 23/5. And that can be written as 4 3/5 as a mixed number. Number 13, I like this problem. So we're going to let's rewrite it with a little space. So the inverse is going to be 4/-7, 4/-7. The 4's cancel to 1's. The -7 becomes -1, and the 7 becomes 1 because 7 goes into 7 once. 7 goes into -7 -1 times, and you're left with 1. No, let's make it the right color. You're left with 1/-1 equals n. You cannot leave it like that. 1/-1 simplifies to -1. 2/5 p equals 4/5. We're going to multiply by the reciprocal. 5/2. 5/2. 5 becomes 1. 4 becomes 2. 2 becomes 1. And p equals 2. 2/1, which reduces to 2. That is 5/2 equals 5/8 p. multiplied by the reciprocal, which is 8/5. The 5s are going to cancel. The 8 becomes a 4. The 2 becomes a 1. And that gives us 4 equals P. That's good. And last but not least, let's convert them. That's negative 9/4 n equals 9/8. Multiplied by the reciprocal, which is negative 4 over 9. Notice the reciprocal. Doesn't matter where the negative is. It can be in the numerator, it can be in the denominator. It just needs one of the negatives. One of them needs to be the negative. It could have been on the outside, right along the fraction bar. That's going to leave us with n. The 9's cancel. The negative 4 becomes negative 1. 8 becomes 2. So we get negative 1/2. And that should be all of the correct answers. So, thank you. Good luck. Come and see me if you have questions.